All right, guys. Next thing we're going to talk about is exponents and exponent rules. Okay, so start out with just a couple things about exponents before we get into all the rules. This is the form you're going to see. It's going to be something raised to a power. Okay, that something is called the base. All right, it's the big number on the bottom, and then the little number is called the exponent. Okay, so what does this notation mean? It means we multiply the base x by itself a number of times. All right, so if I were to ask you to write this out in expanded form, you write out a number of x's. Of course, a is going to be an actual number in the problem, not just a name. Okay, one thing I want to remind you of, these rules only really work with monomials. So monomials are a single term. That means nothing in the problem is separated by a plus or a minus sign. And these properties only work this way on monomials. You never want to try to apply them on polynomials. So if you do have something with more than one term, you can't really use these rules. So first thing I'm going to have us do is just write these out in expanded form and then evaluate if we can. Okay, so 2 squared, expanded form would be 2 times 2. And to multiply those together would be evaluating, that equals 4. All right, it's pretty easy. Okay, if you want to pause the video here, give these next two a shot. Okay, you work in the same way. So this one you have to expand out, 3 times 3 times 3 times 3. Okay, to evaluate this, I would kind of just multiply these two together. 3 times 3 is 9, I know what that one is. Multiply these two together, same thing. And then multiply 9 times 9, and you get 81. So 3 to the 4th equals 81. Do this one the same way. You got 4 times 4 times 4. Okay, so that's 4 times 4 is 16 times 4, which is 64. All right, last one over here. You can also see exponents with a variable base. This one we won't be able to evaluate, but we can still write this out in expanded form. 6 x's. And that's as far as you could go there. All right, so our first rule is going to be multiplying like bases. So again, you can only do this with a monomial, so no plus signs or minus signs, and then the bases of the values have to be the same. So 2 squared and 2 cubed, and we're multiplying those together. So you can use expanded form to kind of figure out how this rule works. So that's what we're going to do here. So first thing I'm going to do is write both of these out in expanded form. That's 2 times 2 and 2 times 2 times 2. Okay, we can get rid of the parentheses because they're not really necessary since all we're doing is multiplying everything together. And then I have 2 times 2 times 2 times 2 times 2, which if you multiply that all out is 32. Okay, but what I'm more interested in is what would that look like as an exponential? All right, so I kind of pointed from here to here, but really I want just to look at what would this be as an exponent. And there's 1, 2, 3, 4, 5. 2 to the 5th. All right, so what do you think the rule is that's happening here? How can we get from the first step to the last step without going through this whole process every time? The answer is you add the exponents. 2 plus 3 is 5. So multiplying like bases, the rule is you add the exponents. Easy as that. All right, let's try a couple of examples down here. So we've got 2 cubed times 2 to the 5th. So we use our new rule that we just learned about, and we get 2 to the 8th. Okay, now when you have just numbers like this, we most of the time want you to go ahead and multiply that out and evaluate it. 2 to the 8th is a pretty big one, okay, and we could do it in our head and by hand if we wanted to, but we have these calculators. All right, so let's put them to use on something like this. This is a great thing to use the calculator for. 2, the exponent button is this one over here. It's under the equal sign. Looks like a little housetop. It's called a caret. Power of 8, enter, so that's 256. All right, x times x to the 4th equals x to the 5th. All right, anytime there's a value without an exponent, that's assumed to be an exponent of 1, and 1 plus 4 is 5. Can't evaluate that because we don't know what x equals, so that's as far as you can go with that. Okay, this one, it kind of looks like it's like 3x to the 5th and 3x to the 4th, but it's not. The exponent actually only applies to the x's, not to the 3's. Okay, so you really want to think of it like this: 3 times x to the 5th times 3 times x to the 4th. So let's start with the 3's. Those are like bases. They're the same. Their exponents are both 1. So that's 3 to the 1 plus 1, or 3 squared, and then x to the 9th. Okay, we can't do anything with x to the 9th, but we can do 3 squared, which is 9x to the 9th. All right, and just as a little side note, if these had been in parentheses, this would be a totally different answer. Okay, if that's in parentheses, then it's 3x to the 5th and 3x to the 4th, and your answer would be 3x to the 9th in parentheses. All right, so there's a couple other rules we have to talk about before we can get to that sort of thing, but I just wanted to make sure you're clear about parentheses versus no parentheses. All right, so maybe give this one a try on your own. Pause the video, come back, and see how it's done. All right, so just add the 2 exponents for the j, add the 2 exponents for the k. You got j to the 9th, k to the 12th. All right, next one is called power to a power. All right, gets its name because you're raising a base to an exponent and then to another exponent. All right, so a lot of times you'll see parentheses and exponents on both the inside and outside. We can use expanded form once again to kind of create how this rule works. So first thing I'm going to do is write out 2 squared 3 times. That's the exponent of 3. Okay, then within each parentheses, I'm going to write out 2 times 2, because that's what 2 squared is. Now again, since everything's being multiplied together, we don't need any of those parentheses. So it's just 2 times 2 times 2 times 2 times 2 times 2. If you multiply all those together, you get 64. Again, not so interested in the 64. I'm more interested in what would this look like as a power of 2. Okay, and again, it's pretty much going straight from that step here. How many 2's were there? 6. So how do we get from the top step to the bottom step in one step, skipping over all this stuff? And you can probably see that you multiply the exponents. Okay, so power to a power rule, you multiply the exponents. All right, let's see if we can put this rule into use. So I've got 3 to the 3rd to the 4th, 3 to the 3rd to the 4th. So I multiply 3 times 4, and I get 3 to the 12th. Again, with just numbers, we usually like to evaluate that. 3 to the 12th is much too large to do in our head, so we pretty much have to use the calculator here. All right, and no problem in the calculator. 531, 441. 531,441. So you can see how big exponents get really, really quickly. All right, so this one, we've got 2 cubed squared. So that's going to be 2 to the 6th. Then we're going to multiply that by 3 squared squared. So that's 3 to the 4th. All right, evaluate each one of these separately. We're not allowed to multiply these together because they don't have the same base. So we can't use that multiplying like bases rule. But we can just make them regular whole number and then multiply them together just like we normally would. And actually, since we're going to use the calculator anyway, we can just type that straight in and it'll get the answer for us. So we do 2 to the 6th. Make sure to arrow out of the exponent so the multiplication happens down here instead of up. And then 3 to the 4th. 5,184. All right, so next one we've got x to the 9th to the 6th, and you multiply those together and you get x to the 54th. All right, and last example over here, we've got a couple of different power to powers. So x to the 7th to the 5th, that's x to the 35th, multiplied by x cubed cubed, so 3 times 3 is 9. All right, unlike the second example where we didn't have like bases, this one we do have like bases. So we actually can combine these together using our multiplying like bases rule, which says we could add the exponents. 35 plus 9 is 44. So x to the 44th would be our final answer there. All right, power of a product. So this is when you raise two things that are being multiplied together to a power. So 2 is being multiplied by x. We're raising both of those to a power. So this kind of alludes to the parentheses thing I was talking about a couple of slides ago. All right, we can use our expanded form once again to kind of derive how this rule works. So start by doing 2x times 2x. I don't need the parentheses because everything's being multiplied together. And the commutative property says I can just rearrange these in any order I want. So I'm going to put the 2's next to each other and the x's next to each other. Multiply that back together and you get 4x squared. Once again, though, I'm not really interested in 4x squared as an answer. I'm more interested in what happened to that exponent. How did the 4 and this x squared come to be? So again, kind of from that step, how many 2's are there? 2 2's. How many x's are there? 2 x's. So look at the original and look at our answer, and what do you think happened there? Okay, so when we have power of a product, we have to distribute the exponent to every value inside the parentheses. Okay, I use that distribute in quotes because it's not like normal distributing. You're not multiplying everything by 2. You're applying the exponent to every item inside the parentheses. Okay, this is really where the whole monomial versus polynomial comes into play. You can only do this if there are no plus signs and no minus signs inside your parentheses. Okay, if there is a plus or a minus sign, then this doesn't work. So you have to look for another way to work it. So let's see some examples. 3x all raised to the 4th power. So that means we're going to have to distribute, and the 4th power is going to become an exponent. 3 to the 4th, x to the 4th. Okay, now you got to be real careful. I see this mistake all the time. People just do 3 times 4 and they say that's 12x to the 4th. It is not 12. Okay, it's 3 to the 4th power. Okay, we've actually already done this one, but just to emphasize, type it in. 3 to the 4th is 81, not 12. Okay, you got to be real careful. That's why I don't like that word distribute, because it makes people think multiply. But you're not multiplying. You're applying the exponent to both terms, both items. All right, maybe try this one on your own before you go any further. So pause it, try it on your own. All right, so on this one you have to distribute the 2 like this, so that's 4 squared. This one is a power to a power rule, so that's x to the 6th, and then 4 squared is 16, x to the 6th. All right, so this one, same deal. You're going to distribute that to both, so that's going to be 1/2 to the 6th and x to the 12th. All right, we haven't really gone over the division rules yet, so you can use your calculator for this part. Just put it in parentheses, 1/2. And then, whoops, let's arrow out of those parentheses and do a power of 6, and we get 1/64. X to the 12th. All right, again, maybe try this last one on your own, see if you can get it, and then unpause the video and come back and see if you got it right. All right, you got to distribute that 3 to all 4 items in here. That includes the 3 in the front. So that's going to be 3 cubed, x to the 2 times 3 is 6, y to the 5 times 3 is 15, z to the 8 times 3 is 24. Evaluate the 3 cubed in front, that is 27. X to the 6th, y to the 15th, z to the 24th. All right, we're going to cut it there, come back to see part 2 to get the rest of the properties of exponents.